What if the universe isn't just vast, but truly infinite? It's a question that stretches the mind, a concept so immense it borders on the spiritual. We look up at the night sky, a canvas of countless stars, and feel a sense of scale. But what if that canvas has no edge? What if it goes on and on forever? Infinity sounds simple, a line without end. But when we apply this idea to the physical cosmos, our logic begins to fray. Push on the concept of infinity, and paradox leaks out from the seams. The first and most famous of these is Olber's paradox. In the 19th century, Heinrich Olbers pointed out a startling contradiction. If the universe were infinite in size, infinitely old, and uniformly filled with stars, then no matter where you looked, your line of sight would eventually end on the surface of a star. The entire night sky should blaze with the light of a billion suns, as bright as day. Yet, when we look up, we see darkness. The resolution to this paradox is one of the cornerstones of modern cosmology. Our universe is not infinitely old. It has a finite age, beginning with the Big Bang around 13.8 billion years ago. This means light from the most distant stars hasn't had time to reach us yet. Furthermore, the universe isn't static. It's expanding. Galaxies are rushing away from us, and this expansion stretches the light waves traveling through space, shifting them towards the red end of the spectrum and eventually into invisibility. Infinity meets the constraints of time and motion, and the night sky dims to a familiar, comforting black. But resolving one paradox opens the door to another, even stranger one: the problem of duplicates. In an infinite cosmos, there are only a finite number of ways to arrange particles within a given volume of space. Say, the volume of our observable universe. The number is astronomically large, but it is not infinite. If you have an infinite amount of space to play with, but only a finite number of configurations, those configurations must eventually repeat. Somewhere out there, in a galaxy unimaginably distant, there could be another Earth with another you, living a life identical to yours. And another you who made a different choice this morning. And another, an infinite number of times. This mind-bending idea leads directly to the measure problem. If there are infinite versions of you, how can we make any probabilistic predictions? What does it mean to say an event has a 50% chance of happening, if in an infinite reality, it happens an infinite number of times, and happen an infinite number of times? Comparing one infinity to another is mathematically treacherous. In an infinite set, the word most can mean anything, or nothing at all. To do science, to make sense of the world, we must choose a careful ruler, a measure, to cut infinity down to a size we can manage. This is where our own limitations become a useful tool. Our view of the cosmos is not infinite. We are enclosed within a bubble called the observable universe. This bubble is defined by the cosmic horizon, the absolute farthest distance from which light has had time to reach us since the Big Bang. It's not a physical wall, but an information boundary. Its edge is a surface in time, not space. Beyond that horizon, we can only infer. The simplest assumption is that the universe continues on much as it is within our view. More galaxies, more clusters, more voids. But it's also possible that the fundamental laws of physics are wildly different out there. Infinity hides its secrets just one step farther than we can possibly look. If space is infinite, is time infinite too? Some theories, like eternal inflation, suggest that our Big Bang was just one event in a much larger, eternally expanding multiverse. In this model, space expands so rapidly that quantum fluctuations can cause new regions to bubble off, each becoming a new universe with its own Big Bang, a process that could continue forever into the future. But even here, infinity finds a boundary. The Borda-Guth-Vilenkin theorem, a powerful result in cosmology, hints otherwise about the past. It states that any universe which has, on average, been expanding throughout its history cannot be infinite into the past. It must have a beginning. Even an eternally inflating multiverse likely had a starting point. Infinity in space does not guarantee an infinite past. Time, it seems, still has an anchor. To grasp these counterintuitive ideas, physicists sometimes turn to a thought experiment. Hilbert's Hotel. Imagine a hotel with an infinite number of rooms, all of which are occupied. A new guest arrives. Is there space? Yes. The manager simply asks the guest in room 1 to move to room 2, the guest in room 2 to move to room 3, and so on for all infinite guests. Room 1 is now free. Even if an infinite bus of new guests arrives, there's still room. In Hilbert's Hotel, our everyday intuition about full and empty breaks down completely. Yet the logic holds. Cosmology faces the same puzzle on a cosmic scale. When dealing with an infinite universe, our intuition fails. We must rely on the rigorous logic of mathematics to guide us. When everything is unbounded, which answers count and how much? That is the essence of the measure problem. So we test. We don't just theorize, we observe. We map the cosmic microwave background, the faint afterglow of the Big Bang, searching for patterns that might reveal the universe's overall shape. We track the redshifts of distant supernovae to measure the expansion of space with incredible precision. We weigh the effects of dark matter and dark energy, the mysterious components that govern our cosmic destiny. Each measurement, each data point, helps sharpen our measure of infinity, turning an abstract philosophical problem into a question that evidence can answer. One possibility is that space is finite but unbounded, like the two-dimensional surface of a sphere. You can travel forever in any direction and never reach an edge, yet the total area is finite. Our three-dimensional space could be curved in on itself in a higher dimension, vast but not truly infinite. Or maybe it truly never ends. For now, we don't know. But the paradox is a gift. It forces us to confront our deepest assumptions, exposing the questions hidden within our questions. Until evidence decides, we live with a beautiful tension, a night sky that whispers of infinity, and a cosmic horizon that says, "Not yet, fade out."